Anand Ranganathan. I'm one of the co-founders and the Chief AI Officer at Unscrambl. And today we're going to be talking about how we can explore flood insurance claims data through a new paradigm that we call natural language conversations. So we're going to be showing how we can explore this data as well as uncover interesting findings and create data stories from this data using our product Cubo. So let's get right to it. So let's just first take a look at what this data set looks like. So we're going to take data from FEMA. So FEMA releases data sets about natural disasters, flood claims, flood policies, and other related information. So we're going to export or actually connect this Cubo to this data and start asking questions. So this is a web interface for Cubo. The way you ask questions is by creating a new thread. I'm going to create a new thread in this channel called Flood Insurance Data Analysis. And the way you start analyzing data is by first saying explore. So when I say explore, I'm going to get an idea of what data sets are available. So in this case, we see that there's data about disasters, claims, and policies. NFIP stands for the National Flood Insurance Program. We can take a look at what kind of data exists about disasters, what are the attributes available, what are some sample questions. So for disasters, for instance, we see there's a declaration date, a declaration title, which financial or fiscal year it is declared in, whether individual assistance is provided. For claims, there's information about whether the date of the claim, the date of loss, latitude, longitude, whether the claim came from a house of worship, and lots of very interesting information about claims as well as policies. This explore functionality in Cubo allows you to explore this data, the different attributes available, as well as some sample questions about that you could potentially ask about the data available. But let's ask a question. Let's focus on hurricanes. Right? So let's say you want to find the number of hurricane incidents in New York yearly. So behind the scenes, what happens is that Cubo converts this natural language question into a SQL query to a backend database. So in this case, the database is actually a Snowflake database where we have uploaded this flood insurance claims and other data. So it's converted this natural language query into a SQL query. In this case, though, it came up with 3 different possible conversions. So let's look at some of them. So it's asking, do you want the number of disasters in state of New York with the declaration title hurricanes, or disaster in New York with the incident type hurricanes, or a comparison with the previous year. So I'm going to pick the second one because I really want the type of it to be hurricane rather than the title. And let's look and see what comes up. So here we see, there are relatively few disasters, hurricane disaster declarations in New York until the 90s, and then so the number 2000, 2005, 2012, 2010, 12, 20, and so on. So there's definitely a big spike in 2012. So let's look at that a bit more detail. But before that, we can zoom in a little bit over here. Some of the things that come from as a result from Cubo is an analysis of some information about the data. So for instance, 2012, 5, and 2011 have the highest number of hurricane declarations. In fact, in this data set, each declaration corresponds to one county. So in 2012, in fact, there were 76 declarations of hurricane disasters from various counties in New York. And we can also look at the actual SQL query that got generated. So actually, let me go to that. So this is the actual SQL query itself that got generated that went to the backend database to get the answer. So anyway, let's keep digging into this so I can then go and ask questions like, let's see, what are the hurricane incidents in New York in 2012, since that was the period where we saw the most number of disaster declarations. So again, I'm going to pick the incident type over here, and now we should get a list of all the disaster declarations in New York in October 2012 that related to hurricanes. So when we zoom in over here, we see a lot of these are related to Hurricane Sandy. So we see each individual row corresponds to one declaration. So from Bronx, from Kings County, Nassau County, New York County, and so on. So that's what the data is about. This looks interesting, so I'm going to add this to a board. A board is a collection of interesting findings or interesting charts that I uncover while I explore the data. I want to keep them, and then I can export them and create stories from them, share them, and do lots of cool things with boards. So now we know the what happened in New York over the years, especially 2012. Let's look at the claims, the flood claims that came out of this. So number of claims from New York yearly. So in this case, because this particular data set only has flood insurance claims, if I just say claims, it's going to now match that to flood insurance claims. And I'm going to pick, I want it to be a yearly comparison as opposed to a growth query. So here we see, for instance, an interesting finding here again, a massive spike in the number of claims in New York in 2012. So 58,000 claims, where typically, there were like a few hundred, a few thousand every year before that. So let's add that to the board as well. Let's go a bit deeper. Say, let's focus on 2012. In fact, October 2012, because that's when the hurricanes were, right? The number of claims from New York in October 2012, let's say daily. So exactly, which dates were these claims from? I'm going to again pick the first one over here, and let's see how in October 2012, how did the number of claims change over different days? So again, over here, most of the days were pretty low number of claims, so one or two claims every day, and then on the 29th, there were 48,000 claims, and this is based on the data. And then on 30th as well, there were some number of claims. So I can then dig into the data. Let me say by primary residence indicator. So how many of these claims came from houses that were primary residences versus how many of these came from secondary other residences or even non-residences? So 43,000 came from primary residences, 14,000 did not come from primary residences. I can take in other ways as well. Let's say by condominium indicator. So in fact, without even doing that, one of the suggestions it's come back with is to recommend that I do this by condominium indicator. So here, I'm going to pick that suggestion that Cuba came back to me with. And here it's saying that most of the claims actually did not come from condominiums. Most were perhaps from single family, other dwellings. But a few, for instance, came from individual condominiums, high-rise, low-rise buildings, but most were not from condominiums. Let me add this to the board as well, because it's kind of interesting. Then other ways of digging into the data. So for instance, I can also say by occupancy type and by flood zone. So one of the things you notice here is that this is a very conversational interface. So I can keep asking more and more questions that drill into the previous question. And each time it's going to try to interpret my utterances in the context of previous questions. So here, let me now pick this one and ask it to group the number of claims by occupancy type and flood zone. So for each occupancy type and each flood zone, I get the number of claims filed. This come back to me as a table, but let's see if I can show it in a different view. Let's see a Sankey chart. So here we see that the number of claims, that many of the claims came from single family houses, some from 2 to 4 family houses. Many of the claims were related to flood zone AE. AE is sort of a higher risk flood zone, but many also came from X. X is in fact a lower risk flood zone. So it's kind of surprising that a significant proportion of the claims came from houses that are designated as technically low risk or moderate risk. So that's also, again, interesting. So I'm going to add that to the board as well. Let's ask a few other questions. Let's say top 5 cities by number of claims in October 2012 in New York. So again, Cubo has different ways you can ask questions. You can ask, listing questions, aggregation questions, top K questions like this one, and it's going to try to interpret these. Each of these have their own unique SQL constructs or ways that the SQL looks, and then we get back the answers. So Long Beach had the most number of claims, while some of the other ones had fewer, and so on. Another interesting, you could do also fairly fine-grained questions, a number of claims from, say in October 2012 from Staten Island. by occupancy type. So even a fairly complex, phrasing like this, where there are multiple phrasings, could in fact be understood by the system. So let's move on. I'm going to ask now. So far we've been looking at the number of claims, but this data set also has information about the amount of claims paid. So I could ask questions like, what is the total amount paid on, let's say, building claims in New York in October 2012 by reported city, wherever city it came from. So I'm going to ask that, and now in this case, it's now going to come and ask verification. So I'm going to pick the first one: the total amount paid on building claims in New York in that period of time. So zoom in over here, see what that looks like. So here, for instance, again, Long Beach, like before, had the top amount paid. There's about 363 million, Brooklyn, Massapequa, and others. Let me add this to the board as well. So you could explore the data either through natural language questions or through a UI interface where you can customize the data. So apart from total amount paid, let's say I also want to know the average amount paid. What is the average claim? Let's say I'm going to add this average amount paid as one of the metrics. And now let's see what that looks like. So we can compare for each city what's total amount and the average amount, which could be an interesting comparison. So while that's coming up, what system again is doing behind the scenes is each time you ask a definement question, it converts it into SQL query, gets back the answer, and shows the answer. So here, for instance, we see some interesting clusters of data. There are a few places like Long Beach, which have a huge amount paid, but maybe not, the average is not very high. $68,000 is the average paid over here. But a few other places like Long Island City, where the average amount is 300,000. New York has 252,000 as the average amount paid. So again, we're able to get to this fairly, deep finding for that particular date range in New York pretty quickly. It's just a conversational analysis. A couple of other questions just to explore further. So I could ask questions like total amount paid on building claims yearly. So I'm just stepping back a bit, and instead of focusing on just New York and claims of Hurricane Sandy, I'm going to step back a bit, see what's the total amount across all years, just to get an idea of what that looks like. So here, come back to the table view, but let me change that to a line chart. And let's look at that. So here, there's again a massive spike in certain years. 2005 had a big spike in the building claims. 2008, 2012, 17. I think we not speculate on which hurricanes might have resulted in this massive number of claims paid. Let me add that to the board as well. So one of the features of Cubo is, apart from asking what questions like we've been doing so far, you can also ask why questions. So I could ask questions like, why is the total amount paid on building claim in 2017, as an example, more than the yearly average? So what happened exactly in 2017, where we see one of the spikes over here? What changed in that particular year compared to other years? So this is now a deeper narrative. Let me zoom in. So it's come back and said that the claims in 2017 increased by about 634%. Here, for instance, in general, it's about $1.14 billion paid per year. In 2017, it's $8.4 billion. And some of the key reasons are a big increase in claims paid in Texas. One of the biggest factors over here. That's the first. Other ones are, big increase in claims paid on flood zone X, where X, if you recall, is our flood zones that are supposedly low or moderate risk. There's also increases in not condominiums, increases in single family, and so on. So All these are possible reasons why 2017 had a big spike in the amount paid. I'm going to add that to the board as well. So once you add these to the board, you can actually export them out. You can share them, you can email them out, you can download it as a PDF, you can download it as and create a story out of it. So the story aspect is in fact one of the newest and neatest features, I believe, of Cubo. So when you create a story, you can actually embellish it. So here's an example story I had embellished. So we had a base story that Cubo generates, but here's an example way in which Cubo, you can embellish the story manually and then export it out. So here I've exported as create a new data story. I'm going to pick a set of visualizations, maybe all of them, and I'm going to say create a story from this and say I'm a team, for instance, and I can create a summary and export it as a video. I won't do that right now because that takes a few minutes, but I had done this just a while back, so I'm going to show what is created a bit earlier.
Dramatic spikes in claims from low and AMP. Moderate risk flood zones necessitates a review of flood zone classifications. Since 2017, flood-related claims from areas of the country that are considered low-moderate risk have been increasing dramatically. In fact, they are almost as much as claims from high-risk flood zones. This is true for both the number of claims and the monetary claim amount.
So I'm going to pause the video story here, but the video story is a unique way for now sharing insights about data in an easy fashion. So in this way, data scientists, data analysts can create more engaging presentations or content about the analysis they've done and share it with the stakeholders. So these stories are created either completely manually. User can pick their charts that they've explored using natural language conversations and then formulate a story. Or Cubo can also suggest stories. So one of the features of Cubo is set of analytics. We already saw some analytics about why questions. We also have other predictive analytics, so the clustering, harm reduction analytics. And all of them can also generate stories, which could be a starting point for creating video stories. So for example, some of the stories that we see here from Cubo came up with, let's look at it. So some of these are findings from Cuba. So one of the findings is Florida has a strong association, surprising initially for me, strong association with freezing disasters. So Florida has way more freezing disasters than, and here are some associations or correlations between states and disasters. So California fires, Louisiana coastal storms, Maine biological disasters. Biological, by the way, includes pandemics as well. Here are some other findings from Cubo. Iowa surprisingly has a low length of disasters of type tornado. Claims paid in Minnesota from the National Flood Insurance Program is very low. The average insurance average insurance premium of policies in Texas from flood zone V11 is very high. And this is natural language generated by Cubo itself, explaining this story or explaining this concept. So user can take this and then further enhance it and then create a story from it and share it if they find it interesting and meaningful. So that concludes the demo of Cubo. I'm going to stop here and happy to take any questions. Feel free to reach out to us and happy to work with you to help you explore and create stories from your own data through natural language conversation.